Hey there. I'm going to try to explain this problem before tutorial start today. So I'm going to go a little bit quick. So you can watch it again if I go too fast or ask me questions. All right, so we've got this elevator that's moving up here. Depending on whether we've gone above 21 meters or not will determine whether the angle is shrinking or growing. So this angle will be shrinking until we hit this point, and then it'll be growing. So when we look at this case, the angle is going to be shrinking. When we look at this case, the angle is going to be growing. The whole time, the rate of change over here, I'm going to call this y. So dy dt is 4 because the elevator is rising at 4 meters per second. My x is 20 and it's not changing. So my dx dt is 0. Now the common mistake is that kids will think that y is 11. But y is not 11. Like my y value is going to be 21 minus the height. So if this is 11, then my y value is 10. So at this point, y is going to be 10 when I draw my triangle. For the other one, when I'm 41 meters away, 41 minus 21, that's going to give me y equals 20. So for the first part, we're going to use y equals 10, and the angle will be shrinking. So theta is shrinking. And then for the second part, we're going to use y equals 20, and theta will be growing. All right, so let's take a look. Since we have information about the opposite and the adjacent side to theta, then we're going to want to use tangent. So tangent of theta would be, y over x, not x over y. So we want to do opposite over adjacent, so y over x. And x is a constant, so I want to just plug that in right off the bat. So y over 20. Now we can take the derivative. Since it's meters per second, we want to take the derivative with respect to time. So secant squared theta d theta dt equals 1/20th dy dt. We know dy dt is 4. Now, for this part of the problem, we'd say dy dt is -4 because the y value is shrinking. For this part of the problem, we'd say dy dt is +4 because the y value is growing. To get d theta dt, because we want to know the rate of change of the angle of elevation. So this is what we're solving for. To get it by itself, you can either divide both sides by secant squared or multiply both sides by cosine squared. I like to think about it that way. So 1/20th dy dt times cosine squared theta. And at this point, we're dealing with a triangle, that looks like this, where you've got 10 over here and 20 here. So let's figure out what theta is. Theta would be the inverse tangent of 10 over 20, because you'd say tangent theta equals 10 over 20, so take the inverse tangent. So let's do that on the calculator real quick. Inverse tangent of a half would be 0.4636 radians. So I'm going to plug that in for theta here. Dy dt, we're going to say is -4, and that's how we're going to get a negative rate of change for our angle. So d theta dt equals 1/20th times dy dt, which will be -4, times cosine squared of 0.4636. Let's see what that gives me. So I got d theta dt equals -0.16 radians per second. Now, for some reason, when I looked at the MathXL answer choice, it had a positive 0.16 radians per second. On the AP exam, you'd want to specify that this angle was shrinking. So you'd either say that the rate of change is -0.16 radians per second, or the rate of change of the angle is decreasing at 0.16 radians per second. Everything would be exactly the same for the second part, except our theta value is going to be different. I'm going to let you work that one out on your own. But you'd start out with the same tangent equation. You'd start out with the same secant squared. This is going to be a +4 for that second case. And like I said, this angle will be different because the triangle that you would need to draw over here would still be 20 here, But if I'm at 41 meters above 21 meters, then my y value is 20. You can also see that theta is going to be like a 45-degree angle, which is pi over 4 radians. So again, I'm going to let you work out that second half. If you still have questions after watching this, let me know, and I can talk through it some more.